Hello. Today we are going to do a card sort on Desmos where you look at both the roots and the end behavior. So kind of putting together what we've talked about with polynomial functions. So I have it pulled up here on Desmos so that you can see what this activity is going to look like. Remember, please put your real name, and I would like you to put your class period and then your last name and then your first name. Kind of like I have up in the corner here as an example. I have 8 Freeze, Michelle, as though I was in 8th period. And that way it's easier for me to enter your grades because I just pull them directly from Desmos for this. You don't have to submit anything on Canvas. So on this directions page that comes up, it says that you're going to do 2 card sorts. You're not. You're only going to do the first one. So there are only 4 slides there. You're only going to do the second slide. So let me go over so you can see what that will look like. So here's the slide when you first pull it up, and what's that equation thing? Let's hide that. There. So it's got lots of cards on here, and these are movable. You can like slide them around. So what I would do is let's take your equations first and put them across the top. So I do not know what is happening. So let's just take these equations and slide them across the top here. Do not know what those blue boxes are. So there we go. Got them slid across the top here. And then I would go through and choose one and analyze some stuff about it. So if I'm looking at this first card here, it's in factored form, so that means I can pull the roots from it, the intercepts, the x-intercepts. So if I look at this first factor, it says x plus 4. Well, I know that the root that would go with that is x equal a negative 4. So I want to find a card, and I think I would look at the yellow cards next if it was me. I want a yellow card that's going to talk about having a 0 at negative 4 from this first factor. If I look at the second factor, I see an x plus 2 there, so the root that would go with that is x equaling a negative 2. And then the last one has an x minus 2, so that would give me a root of 2. So negative 4, 2, and positive 2 are the 3 numbers that I'm looking for. None of those factors have an exponent on them, so I don't want a card that mentions anything about multiplicity. So I think this is the card that I want. Negative 4, negative 2, and 2. Yep, those are going to go together. So you're going to make the cards in little lines. You're going to stack them up, kind of. So from there, I think I would look for a graph. So let me move these around a little bit so I can see the graphs better. Let's see, I'll just put it, oh, I don't want those 2 stacked. Put that over here. So let's see. If I want to think about the graph of this, I need it to have zeros at negative 4, negative 2, and positive 2. And those are all going to be passed through. Since there's no multiplicity, there's not going to be any bounces. So it's not going to be that one because it bounces off at the 0. It's not going to be this one because it bounces off at the negative 2. It's not going to be that one because it's got bounces. I have a feeling it's going to be this one. Let me look. So it says negative 4. That would be a root right there. Ooh. Negative 4. And negative 2 and positive 2. So that has the zeros that we need. So that's going to be the graph that goes with this equation. Now I need a blue card. And the blue cards have descriptions of the degree and the end behavior. So if I look up at this equation, I'm going to see how many x's I have that are getting multiplied together in my factors. So here's an x, here's an x, and here's an x. So that's x to the third would be the highest degree that I would see here. So it's going to be degree 3, which there's only one card that mentions that, so that's good. So I'll bring that over. Now to read end behavior, remember end behavior talks about as x approaches negative infinity or positive infinity. So that's how you say mathematically it's going to the left or going to the right, and then it tells you what the y will do with each of those things. So if I look at this first graph here, I can see as I go to the left, the y's are going up very high. So remember, we start at the origin, and then see what happens as you go way out to the left. Well, way out to the left, it's going up. So that's what this second line is telling me. It says as x approaches negative infinity, that's how you say left. Y is approaching positive infinity, that's how you say up. On the right hand side, I see the graph going down, and that's what this first line here says. It says as x approaches positive infinity, so that's how you communicate that you're going to the right. And as we go to the right, this graph goes down, and the way to say that is y approaches negative infinity. So there's the first set. So you want to sort the other cards, see what goes together, and then I want you to open up another tab of Desmos and graph these 1, 2, 3, 4, 5 polynomials and see if your graph matches what is on the cards. That way you'll know that you did them correctly. So, well, I think that is everything. So remember that Jesus loves you, and so do I, so do your math.